Hello everyone, welcome back to Rust programming tutorial. In the previous lecture, we learned about how to create new threads using thread.spawn. We learned a little bit about closures. We saw what a closure is. We were familiarized with the word move, how to transfer the ownership of a variable in a thread. We also learned about joins, how to make one thread wait for another. Today's lecture is continuation of that. Today we're going to see different ways, or rather a specific way, messaging between using messages to communicate between two threads. If you have to pass data from one thread to another using messages. Okay. Now messaging is very popular because what it does, it is asynchronous communication. Okay, messaging is used in a lot of what do you call it? Reactive way of communication. It's becoming more and more popular rather than trying to have one thread blocked and the other thread also blocked, resulting in deadlocks and all. So, in order to avoid that, messaging is the best way to communicate between them. So when you talk about a message, so let's say, for example, you're sending a message from your cell phone to somebody else, you are a sender and there is somebody a receiver. And you use the cell phone as the channel of communication. So that is sharing messages. So to accomplish message sending concurrency, Rust has a library. Okay, it provides an implementation of channels. Now it's in the standard library. Okay, a channel, what is a channel? It's a general programming concept by which a data is sent, right? So how is data sent from one to another? It's through a channel. So the channel has two parts: transmitter, somebody who's sending, and a receiver who's receiving the message. There could be multiple transmitters also. Now, a channel is supposed to be closed if either the transmitter or the receiver is dropped for some reason, network issue or some other issue. Okay, then the channel is closed. How do we create a new channel? We use the MPSC, this library, and of this library, of this crate, we call the channel function. See, MPSC stands for multiple producer and single consumer. So multiple producers can use this and send messages, but there is one single consumer out there. Now this function, the channel function, when you call it, returns a tuple with two values, a transmitter or sender and a receiver. You move the ownership of this using the move here. You move the ownership of this using the move. You pass it, generate some value, and send it. So this is how you send it. Now there's a main thread that is running here, which uses this rx.receive. So it receives. We are going to see it in demo. So the send method, it sends a result, the type T, or whatever you're sending. So in this case, it would be a string or an error if it's unable to send, or if either the channel, the transmitter or the receiver is closed. The receiver has two methods. One is receive in this example, and there's another one, try receive. The main difference between the two is try receive is non-blocking. So when the main thread comes to this method or it's on this line of execution, it will stop. It will suspend all other executions, all other tasks, and wait until it receives a message. So it's blocking, right? It's blocking the main thread. Whereas try receive, what it will do is if the message is not there, it won't block the main thread. It will continue doing other functions and then again go back and try and see if there is any message. Okay. So The try receive method does not block, but instead it will return a result similar to this. Okay, an OK value holding a message if any is available, and an error if there aren't any messages available at this point in time. Okay, so simple concept. We use multiple producer, single consumer on this package. We use the channel function, which returns a tuple, which is a transmitter and a receiver. In one thread, we move the ownership of the transmitter and send the message. It could be anything. And in the other thread, you receive the message. Two ways, receive and try receive. Okay, receive is blocking call. Try receive is non-blocking call. Okay, let's see it in practical demo. All right, so here is our example. What we are doing is sending multiple messages. So here is a vector with multiple strings. You're sending it, and this is the receiver. Okay, you send, you sleep, and the receiver just prints whatever messages it receives. Okay, so let's see it in action. Here it is. Got hi, got from. As you can see, there is a 1 second delay, right? So you can send multiple values also. So again, look here, it's a spawn. We moved the ownership. We created a vector of multiple or a collection of multiple values, and we are sending one value at a time. Okay. This is just the sleep, which puts the thread into a sleep mode and then gives this method, the main thread, the priority. Okay. Notice the use of the library, MPSC, thread for creating, duration for the sleep. Okay. Now let's see an example of multiple threads, multiple transmitters. So here, if you see, we created a channel, a transmitter and a receiver using channel, and we cloned the transmitter. See TX1, we cloned it. That's how you create multiple transmitters. So from the first thread, what you're doing is using tx1.send, and in the second one, what you're doing in the second thread, what you're doing is using this is tx1 and this is tx. So two transmitters sending, each one sleeping, and then one receiver here. So we should see alternating messages, hi, more, from messages in the order this way. It doesn't make any sense for now, but again, it's just a demo to show how to send multiple messages. Let's run it. So see, one message from here, one message from here. Okay, because it goes to sleep, right? That's why. So alternating messages from alternating threads. And it gives other thread a priority because of the sleep. Okay. Let's see what happens if we don't give the sleep. See, high from the thread. So because it did not sleep, it did not give up its priority, and it was all the time occupying the CPU, defeating the purpose of concurrency. Okay? So that's why it's important for the thread to go to sleep or just release the control of resources so that other threads can process. That is all for today. In the next lecture, we will discuss about mutex, or how to communicate between threads using shared memory data, or mutual exclusion or mutually exclusive data. That's another way of communication between thread. Thank you for your attention and time. See you all again in the next lecture. Thank you. Bye.